In 1984, astronaut Rakesh Sharma looked out the window of a Soviet space station and became the first Indian citizen to see his home country from orbit. From that altitude, the Indian subcontinent looks like a single contained world. It's bordered by vast oceans to the south and sealed off from the rest of Asia by a massive icy wall of mountains in the north. But zoom in and that visual unity fractures. Within these borders, you'll find ancient tropical rainforests growing right alongside hyper-fertile plains, vast stretches of golden sand dunes, and freezing high-altitude terrain that looks more like the surface of the moon. How does a single landmass sustain such violent environmental extremes right next to each other? This diversity exists because every landscape is part of a single hydrological system where the movement of water dictates the reality on the ground. About 50 million years ago, the Indian landmass smashed into Eurasia. The immense pressure of that ongoing collision crumpled the Earth's crust upward, creating the Himalayas, a mountain range that is actually still growing taller by a few centimeters each year. Pushing that high into the atmosphere turns these peaks into the water tower of Asia. They trap millions of tons of frozen water in massive glaciers, suspending a vital resource miles above sea level. But this towering ice wall has a secondary effect. It's so high that it physically blocks rain-bearing clouds from traveling further north, creating what meteorologists call a rain shadow. That blockage creates places like Ladakh. Despite being nestled directly inside a snowy mountain range, Ladakh is a freezing, arid desert. It receives almost no rain, leaving a rocky, barren landscape where winter temperatures drop 30 degrees below zero. The barrier effect of the mountains alters the environment so drastically that the little water that does pool here behaves strangely. Minerals from the surrounding dry rock dissolve and concentrate in the valleys, resulting in striking blue lakes that are entirely composed of saltwater, sitting over 14,000 feet up in the sky. Further south, the cycle is entirely different. When summer temperatures rise, the Himalayan snows melt. This sends billions of gallons of water rushing violently downward, forming massive rivers like the Ganga and the Brahmaputra. These rivers act as a geological conveyor belt. Tearing through the mountains, the water physically scrapes off essential minerals and soil. Over millennia, this water has continuously spilled out and deposited its cargo, engineering the Gangetic Plains, a vast, incredibly flat, fertile expanse. That flat, nutrient-dense terrain is perfect for multi-cropping agriculture and building extensive road and rail networks. Because it is so easy to farm and navigate, this specific stretch of land supports hundreds of millions of people. The Gangetic Plains are the physical results of this delivery system, a land built by the rivers. But move westward, out of the reach of those river networks, and the moisture vanishes entirely. This is the Thar Desert, an arid expanse defined by scorching heat and massive ridges of wind-shaped sand that can rise hundreds of feet into the air. Absolute water scarcity demands radical adaptation. For generations, people living in the Thar have conserved every single drop, to the point of using the abrasive desert sand itself to scrub their daily cooking utensils clean, saving water only for a final light rinse. They also engineer deep underground rainwater harvesting systems called tankas, capturing whatever rare moisture falls from the sky to ensure their families have drinking water through the hottest months. This hostile desert would naturally continue spreading eastward, but it collides with the Aravalli Hills. At 2.5 billion years old, this towering ridge of rock is one of the oldest mountain ranges on the planet. The Aravallis serve a vital protective function. They act as a massive physical shield, intercepting weather patterns and stopping the windswept sands of the Thar from migrating eastward and migrating into the fertile plains. Traveling further south brings us to the Peninsular Plateau, a raised triangular landmass that is actually older than the Himalayas themselves. The western edge of this plateau is guarded by a towering wall of mountains known as the Western Ghats. When heavy, seasonal monsoon clouds roll in from the Arabian Sea, the mountains physically intercept them. The clouds hit the steep slopes, forcing them to dump massive amounts of rain. This immense water capture creates a natural gradient. The runoff from the Ghats pools together and forces major rivers like the Godavari and the Krishna to carve their way completely across the plateau, flowing from west to east. As these rivers cut through mineral-rich rock, They sustain ancient tribal communities, adapted wildlife, and thick forests across the south. When we pull back out to the orbit of that Soviet space station, the entire map recontextualizes itself. The ancient Aravalli ridges guard the plains, the towering Himalayas feed them, and the Western Ghats water the entire southern plateau. This hydrological cycle dictates the culture, survival, and national character of over 1 billion people.